This video is going to talk about dividing decimals by whole numbers. We've talked about this on a previous video, but remember that to divide a number by 10, you move the decimal point one place to the left. First off, if we look at this number 17, it doesn't look like it has a decimal. Remember that when you don't see the decimal in a number, it is at the end of the number, like a period in a sentence. Now, when we go to divide 17 by 10, remembering that in the number 17, the decimal is at the end, like a period in a sentence, when we divide by 10, we are going to move that decimal one space to the left to get 1.7. Let's go ahead and take a look at what this would look like on these various numbers. So we see 45 divided by 10. Going to take the number 45, put the decimal at the end, move it one space to the left to get my answer of 4.5, or 4 5/10. For the number 3, there's no decimal in the number 3, so I'm going to find it at the end of the number. And I'm going to move that decimal one space to the left for an answer of 0.3. I could also write this as 0.3. Either one of these are acceptable. This way is the way to kind of help people make sure that they can see the decimal. 0.4 divided by 10, or 4/10 divided into tenths. We're going to shift that decimal one space to the left for 0.04, or 4/100. And then for 13 4/10, shift the decimal one space to the left for an answer of 1 34/100. How many places would you move the decimal if you were to divide by 100? So 100 is just dividing by 10 twice. Or we can see that there are 2 decimals in the number 100, so we would shift that decimal 2 spaces to the left. The number 1000 has 3 zeros, so we would shift that decimal 3 spaces to the left. Let's go ahead and take a look at what this would look like on these different numbers. For the number 342 divided by 100, I'm going to move the decimal one space to the left for every 0 I have. So if I have 100, that's 2 zeros. So I'm going to take the number 342, and the decimal is at the end, like a period in a sentence, and I'm going to shift this 2 spots to the left. So I have an answer of 3 42/100. For the number 84, this is being divided by 1,000. To divide by 1,000, you're going to end up moving the decimal 1, 2, 3 times. So we're going to shift this 1, 2, 3. Now, there's nothing here, which means as our placeholder, we're going to put the number 0. So this answer would be 0.084. Do you need this 0 at the front? Not exactly, but it's there to help kind of point it out and make it more clear. When we look at letter C, 90 divided by 100, we're going to end up moving that decimal 2 spaces to the left for an answer, 1, 2, of 0.9, or 0.90, or 0.9, or 0.90. Oh, well, I already did that one. Or 0.90. All of these all mean 9/100. The most mathematically correct and clear one would be this one. If there's nothing before the decimal, you normally put a 0, but all of those all mean the same thing. Lastly, for 23 45/100 divided by 1,000, that's 1, 2, 3 zeros. So you would shift the decimal 1, 2, 3 spots to the left for an answer of 0.02345. There you go. Now, we can look at how many places the decimal did move on these numbers. For example, on 543 divided by something equals 54.3, I know that the number didn't change. It's just where the decimal is. The digits in the number didn't change. So that means I either divided by 10, 100, 1,000, something along those lines. So if we look and we see how many spots did the decimal move from being at the end, like a period in a sentence, to being between the 4 and the 3, well, that's 1 time. So we divided by 10. What about in 45? Divided by something equals 0.045? Well, the decimal starts at the end like a period in a sentence. How many spaces do I need to move that decimal in order to get that number? Well, I need to move it 1, 2, 3 spots to get that number. So that would have been divided by 1, 2, 3. That would be 1,000. Take a minute, try to figure out what these numbers were divided by. Pause the video, try on your own, and when you come back, we'll talk about it. Welcome back. So let's take a look. 74 to 0.74, that's 1, 2, so that's divided by 100. 8 divided by something equals 0.008. That looks like that decimal is moved 1, 2, 3 times, so that's divided by 1,000. 90 divided by something is 9/10. That decimal is moving twice, so that's divided by 100. 745 to 74.5. That's the decimal moving 1 time, so that's going to be 74. Nope, just kidding. That's going to be divided by 10. 830 divided by something is 8.3. That's that decimal moving 1, 2 spots to the left, which would be divided by 100. This number here, moving the decimal from here to where it's at here, that's 1, 2, 3. That's going to be divided by 1,000. Now, let's say that we use a tens block as a whole. If we want to distribute 34 tens among 4 people, we want to figure out how many did each person get. So if I have 32 tens blocks and I want each person to get the same amount, well, I would take 32 and I would divide it by 4. And when I divide 32 of those divided by 4, I will end up getting 8. What if I look at a ones block? A ones block, this is 1/10 of one of these. I still want to distribute 32 of these ones blocks amongst 4 people. Well, I had 32 in either case, so both of the times I'm dividing them amongst 4 people. This time, when I get the answer of 8, here's what I need to keep track of. Remember that 1 block is 1/10 of a tens block. So if people are going to get, if I have 32 ones blocks, that 32 ones blocks is the same as saying 3.2 tens blocks, because 32 of these would make 3 whole tens blocks and 2 left over. So instead of having 8 entire tens blocks, people are only going to get 8 single blocks, which means they're only going to have 0.8 of a whole, or they'll only have roughly this much right here. So let's take a look at these problems. 28 divided by 4 is 7. So 2.8 divided by 4 is going to be, well, 28 divided by 4 is 7. If I take the decimal out of 2.8, it becomes 28. 28 divided by 4 is 7. But you notice how we shift the decimal 1 spot here? I'm also going to shift the decimal 1 spot in the answer. What about 48 divided by 6 equals 8? Cool. 4.8 divided by 6. Well, if 48 divided by 6 is 8, I only move the decimal 1 spot here, which means I move the decimal 1 spot here. Last question, 834 divided by 3 is 278. I'm going to take their word for it. So 83.4, which has the same digits as the original number, it's just got the decimal in a different spot. If the decimal shifted one spot here, my answer of 278 is going to have the decimal shift one spot for an answer of 27.8. All you're doing is shifting the decimal the same amount in the original number as in the answer. You can change the order of the numbers you're dividing by and still get the same answer. When you divide by 10, dividing by 4 gets the same answer as dividing by 4. Then dividing by 10. It doesn't matter which order you pick it in. The second expression divides a whole number by 10, which you already know how to do. What we're going to do now is we're going to rewrite these division statements so that they are the final division is by 10, 100, or 1,000. So 0.36 divided by 9, we could remember that 0.36 is the same as 36 divided by 100 divided by 9. 36 divided by 100 is that 0.36. I can also look at 36 divided by 9 first, and I can get 36 divided by 9 divided by 100. We can set the same thing up over here. 0.45 divided by 5. Well, the first thing I can think of is 45 divided by something to get that 0.45, and then divide by 5. I need to divide by 100 to get 0.45, to move that decimal 2 times. But if I switch the order around and I do 45 divided by 5 first, and then divide by 100, I'm still going to get the same answer. So when we look at these problems right here, make sure I didn't skip a page, we don't have to go through writing it out every time. What I can see is I'm going to look at the main division problem first. I'm going to ignore the decimal placement first, and I'm going to figure out what the actual answer is. So I see 42 divided by 7. Sure, there's some zeros in front of it. There's a decimal. We're not going to stress about that right now. 42 divided by 7 is 6. I know this. But notice that this decimal, to get back to the original area, had to move 3, which means that in the number 6, I'm going to move the decimal 3 points to get an answer of 0.006. Same thing in letter D, 3.6 divided by 6. I'm going to ignore the decimal first. 3.6. 36 divided by 6 is 6. I had to move the decimal 1 place to get it there, so in my answer, I'm going to move my decimal 1 place to the left. 0.21 divided by 7, well, that's 21 divided by 7. 21 divided by 7 is 3. So what I'm going to do to figure this out is the decimal had to move 2 spots. So I move the decimal 2 spots here to get my answer of 0.03. Last one, letter F. I can see already I'm going to have to move that decimal 3 spaces. Once I've done that, I know what 18 divided by 9 is. 18 divided by 9 is 2. Move the decimal 1, 2, 3 spots, and I get my answer of 0.002. We could also do this with humongous numbers. I know what 24 divided by 4 is. 24 divided by 4 is 6. Can you tell how many times I would have had to move that decimal? Pause the video if you don't want spoilers. 1, 2, 3, 4, 5, 6, 7, 8. I got 8 counting here, so I'm going to move it 1, 2, 3, 4, 5, 6, 7, 8. That answer would look like that. When we do division and when we see decimals with division in our problems, it's actually easier to solve this way. We have less moving around when we use the traditional division sign that we're used to seeing. So if I know that 6 is going into 42, I need to figure out how many times is 6 going to go into 42. 6 doesn't go into 4, so we don't need to put anything here. But 6 does go into 42, and 6 goes into 42 7 times. 6 times 7 is 42. So I put the 7 where it belongs in the problem. Then all I have to do is show the decimal floating straight up. So that decimal floats straight up, and my answer becomes 0.7, or 7/10. Let's try moving the decimal in the next two. Move the decimal straight up in the problem and put any zeros where they belong so that you can get the final answer. Pause the video if you don't want spoilers. When this decimal floats straight up, I'm going to put it right here. That leaves my answer of 0.09. Then, when the decimal floats straight up here, that leaves my answer of 7. Take a look at how that decimal was floating straight up right there. Now, I like in this one where I have 0.036 divided by 4. I know that 36 divided by 4 is going to end up being 9. So I float that decimal straight up. I'm looking at this problem, I'm looking at the numbers. It's not quite making sense to me right now, so I'm going to double check the math right now. And I'm going to see, what should this answer actually have been? 5 goes into 5 1 time. 5 goes into 0 0 times. And 5 goes into 3. Well, 5 doesn't go into 3, so I'm going to put a 0 here. But 5 goes into 30. And how many times does 5 go into 30? 5 goes into 30 6 times. So, floating the decimal straight up, this would have been 10.06. Why do we get another answer in here? Really hope I don't realize after this video is over, because then I'll have to re-record. So, let's take a look at this division problem. We have 0.02, that was almost an 8 divided by 4. And when I divide this number by 4, can 4 go into 0? No. Can 4 go into 0? No. Can 4 go into 2? No. Can 4 go into 28? Sure. 4 can go into 28. 4 times 7 is 28. So I'm going to put a 7 here. And then I'm going to move my decimal straight up. Notice how I had X's here. Those X's are placeholders that say don't put a number there. You're going to keep going over to see how many times 4 goes into that number. Now that I know where my decimal's going, I might have to put those zeros right there. So my answer would be 0.007. And this is them going over the exact same thing that we just talked about. Go ahead and try to find the final answer to these questions. They've already started them for you. The division is right in all of these. Take a look and see what you can get. Pause the video if you don't want any spoilers. Moving the decimal straight up, we get 0.7, 0.07, 0.007. And for the bonus, you get 0.00007. You could also divide these numbers, and if they didn't have any decimals whatsoever, we would still have answers where we need to put zeros in, but now because there was no decimal in either of the two numbers that we divided by, we're going to put the zeros after. For example, 6 goes into 42 7 times, nothing changes there. 6 goes into 420, well 6 goes into 42 7 times, but I still need to put a number here. So that answer would be 70. 6 goes into 42 7 times, and then there's 2 zeros after. So I put those 2 zeros in. And the same thing right here. So if you see an excessive amount of zeros or blank spaces, what you're going to have to know is that you're probably going to have some zeros in your answer. So they're telling us 84 divided by 3 is 28. So if we know that 84 divided by 3 is 28, that means I know that I can put that answer into the question. In fact, if I were to set it up as a regular division problem without any decimals, it would look like this. You go through and try to figure out where should the numbers line up and where should the decimal be in this question. Pause if you don't want any spoilers. We would put 28 here, 28 here, 28 here, noticing how the numbers stay above the same spot. Now we're just going to float that decimal up. The decimal's at the end here. When it floats up here, we get an extra 0. The decimal's in the front here, so that becomes 0.28. Float this decimal up here, we need a 0. Decimal's all the way at the end here. Float that up, 0, 0, 0. Float that decimal up as well. So we're going to take a look at the steps of long division for 96 divided by 4. 96 divided by 4. Can 4 go into 9? We're going to look at just the 9 first. Yes, 4 can go into 9. And 4 can go into 9 twice. 2 times 4 is 8. 9 minus 8 leaves us 1 left over. When we bring down the next number, that's 6, we have 16. 4 goes into 16 4 times. So we have our answer of 24, and we don't even have a remainder or a fraction or decimal ending on that, which is awesome. So what they want you to do now is you're going to divide as if the decimal point isn't there. Then you're going to put the decimal into the correct place. So let's go ahead, for the sake of time, you're not going to see the full division on here. Go ahead and find a previous video if you'd like to look into division a little bit more. I'm a little bit limited on space and we're already running this video long. But if I take 462 and I divide it by 3, that would get me an answer of 154. That doesn't include any decimals. When I float my decimals straight up, my answer becomes 0.1.54. 3 goes into 176. When I do that, I'm going to get 58. And what you're going to notice is that we're actually going to run a little bit over on that. There's going to be 2 left over. If we were younger, we would call it remainder 2. We're a little bit beyond that in 6th grade. We're going to float this decimal up here, and we're going to take a look. 3 goes into 3 times 5 is 15. We're going to subtract here, and we're going to end up with 2 left over. Bring down the 6. 3 goes into 26 8 times. 3 times 8 is 24. That's going to leave us with 2 left over. Bring down the 0. 3 goes into 20. 3 is going to go into 26 times. 3 times 6 is 18. That's going to leave us with 2 left over. Bring down the 0. 3 goes into 20. 6 times. 3 times 6 is 18. And you're going to see that we're going to continue on with this pattern. This right here is known as a repeating decimal. This decimal will never stop. So what do you do in order to be able to do anything else with your life? We're going to rewrite this number as 0.586 with a line over the top to show that that number repeats. When we solve these digits, we're going to put the decimal here, and if we can get it, okay, right here. It just floats straight up like a balloon. More bonus problems. And then the next thing that you're going to see is even more. Now, you're going to do regular division here, but you're going to move the decimal straight up, and you're going to put it in your answer right here. You're noticing my decimals are significantly larger than you might expect. A, that's so you can see them, and B, the computer, as you've noticed, doesn't always do well with the smaller examples. So if we take a look at letter A, 6 cans of juice cost $4.56. How much does each can cost? Well, if I have 4 56 divided by 6 cans. 6 doesn't go into 4. 6 goes into 45. Well, 6 times 8 is 48. That's too high. 6 times 5 is 30. That's not enough. 6 times 7 is 42. So I'm going to go ahead. 5 minus 2 is 3. So now I have 36. Hey, remember how I said 6 times 6 is 36? I'm going to go ahead and fill that out. My decimal answer is going to go right up here for 76 cents each. That's for each can. A four-person relay has a total distance of 5.6 kilometers. How far would one person have to run? Well, let's divide 56 by 4. 4 goes into 5 one time. 1 times 4 leaves me with a remainder of leftover of 1. Bring down the 6. 4 goes into 16 4 times, which means each person is going to have to run 1.4 kilometers. Last question, you get to compare 3 pencils for $2.34 or 5 pencils for $3.95. Well, the $2.34 divided by 3 goes into 2, it doesn't. 3 goes into 23 7 times because 7 times 3 is 21. That leaves you with 2 left over. Bring down the 4. 3 goes into 24 8 times. So the 3 is 78 cents each. The 5 pencil deal, that's 3.95 divided by 5. 5 doesn't go into 3, but 5 goes into 39 because 5 times 7 is 35. 9 minus 5 is 4. And 5 goes into 45 9 times. The 9 pencil deal is 79 cents. So the 3 pencil deal is slightly cheaper. Ladies and gentlemen, have a wonderful rest of the day.